Welcome to this explainer. You see them in the news literally every single day, right? But today, we're totally peeling back the layers on the true, comprehensive environmental footprint of electric vehicles. Let's dive in and find out what it actually costs to drive emission-free. So, are electric vehicles actually green? It's a super common assumption, honestly, that modern EVs are just perfectly clean simply because they aren't burning fossil fuels right in front of us. But, well, as we're going to see from the data, the real answer is way more nuanced than just a simple yes or no. Now, the undeniable truth here is there's zero tailpipe emissions. I mean, absolutely nothing comes out of the back of the car, and that is fantastic. But it leaves us with a massive question mark when it comes to upstream emissions. To truly figure out if a car is green, we have to play detective and investigate the hidden costs. Things like producing the vehicle and generating the actual power to charge it, well, long before it ever even hits the road, actually. Okay, let's quickly break down the jargon so we're all on exactly the same page. You're going to hear these acronyms a lot. An ICEV, that's your traditional internal combustion engine vehicle, running entirely on standard gas or diesel. Then you've got your HEV, which is a hybrid electric using a gas engine with an electric motor for assist. A PHEV is a plug-in hybrid, so it's got a gas engine but also a battery you physically plug into a wall. BEV stands for battery electric vehicle. This is the big one, the 100% pure electric car. And finally, FCEV is a fuel cell electric vehicle running on a hydrogen fuel cell. For our deep dive today, whenever we talk about purely electric cars, we're really focusing on that BEV category. Section 1, the cost of batteries and upstream extraction. Let's get right into it. To really grasp the footprint of an EV, we absolutely have to look at the heavy, heavy toll of extracting the raw materials that power them. Upstream material extraction comes with some pretty severe localized impacts. For example, a recent report by Down to Earth highlighted that extracting minerals like cobalt, which, by the way, is essential for modern EV batteries, has some serious real-world consequences. The report details how cobalt mining in the Democratic Republic of Congo is actively polluting local air and even physically displacing communities. It's a tough reality. The materials giving us clean air in our cities literally have to be pulled from the ground somewhere else. And that process is not environmentally free. And, the academic world is taking this incredibly seriously. Looking at the current scientific landscape, there is a massive portion of researchers who are just laser-focused on the environmental footprint, the complex manufacturing processes, and the really tricky recycling challenges of lithium-ion batteries. It's like a giant puzzle they're all trying to solve at once. The overarching scientific consensus right now is that the battery life cycle itself is one of the absolute most critical factors in determining if an EV is actually sustainable in the long run. Section 2. The long tailpipe effect and power grid emissions. All right, so we've talked about what goes into the battery, but now we really need to talk about what charges it. Because here's the kicker. Plugging in an EV doesn't magically make carbon emissions vanish into thin air. It simply moves them somewhere else. This is a concept known as the long tailpipe. It's the idea that greenhouse gas emissions from an electric vehicle are effectively just shifted from the car's tailpipe straight down the power lines all the way back to the electrical power plant. This means the true greenness of a battery electric vehicle is entirely, 100% dependent on exactly how your local grid generates its electricity. And wow, this power shift creates a drastic difference depending on where you happen to live. When researchers translate EV emissions into the equivalent miles per gallon of a gas-powered car, the results are just staggering. Check this out. If you plug your EV into the grid in Paraguay or Iceland, where power is almost entirely hydro or geothermal, your EV creates the same emissions as a gas car getting an unbelievable 218 miles per gallon. That is incredibly clean. But look down the list. In the United States, with a grid that's pretty mixed but still heavily reliant on fossil fuels, that equivalent drops down to 40 mpg. In China, where the grid is heavily coal-based, you're looking at 30 mpg. And in India, which relies even more heavily on coal, driving an EV creates the exact same greenhouse gas emissions as driving a 20 mpg gas car. The vehicle is exactly the same, the fuel source changes literally the whole shebang. Section 3. Life Cycle Assessment Explained and Measuring True Impact. So you might be wondering, how do scientists actually go about fairly measuring all of this complex data? Well, the gold standard here is what's called a life cycle assessment, or LCA. As outlined in the International Journal of Technology, this is a standardized analytical tool used to investigate and quantify the environmental impacts of a product across its entire life. It is really the only reliable way to measure everything a car consumes and emits, from its absolute beginning all the way to its final disposal. To pull off a proper life cycle assessment, scientists logically guide themselves through what they call a cradle-to-grave analysis. It starts with step 1.
raw material extraction, like that cobalt mining we talked about earlier. Then it's on to step 2, manufacturing the actual vehicle. Step 3 is utilization. Actually, you'll often hear it called well-to-wheel, which basically accounts for all the energy used to charge and drive the car every day. And finally, step 4 is disposal and recycling. By analyzing this entire chain step by step, scientists can pinpoint exactly where those hidden carbon emissions are sneaking in, rather than just staring at an empty tailpipe.
You can actually see this evolution in academic focus happening in real time. The most cutting-edge areas of research right now are emphasizing how scientists are moving way beyond just looking at basic vehicle performance. Instead, they're systematically tracking that cradle-to-cradle sustainability, they are meticulously mapping out those well-to-wheel emissions and exploring end-of-life battery recycling, trying to get the most accurate, comprehensive picture possible. Section 4. The final verdict. Are EVs the solution? Okay, so after examining the hidden costs of batteries and the long tailpipe of our power grids, we absolutely have to look at the massive potential benefit on the other side of the equation. According to updated data from the International Council on Clean Transportation, battery-powered electric vehicles can actually use roughly 70% less energy overall than traditional internal combustion vehicles. Why? Because electric motors are inherently vastly more efficient at converting energy into motion than gas engines are. The potential for long-term energy reduction here is, well, it's just staggering. Which leaves us with one final, incredibly important question to chew on. Is your electric car only as green as your grid? As we've seen, electric vehicles offer incredible potential for efficiency, but they aren't some magically zero-impact silver bullet. Their true environmental cost is deeply, deeply intertwined with where their materials are mined and exactly how your local electricity is generated. I hope this explainer leaves you eager to investigate what it really takes to power the future right in your own city. Thanks for exploring this with us, and keep learning.